All right, guys, so I'm going to start by really quick showing you this PowerPoint slideshow, just basically show you how you can use this as a resource when you're completing your quiz, if you have any further questions. Basically, I just outline the steps to do your single regressions and your multiple regressions because it is a little bit tricky to find. There's many different kinds of regression. Regression is all about generating predictions. Linear regression is the kind of regression that piggybacks on linear type relationships as we learned about with correlations. So that's why we're learning linear regression. So even though we're dealing with correlational research and there's no, strictly speaking, independent variable that is manipulated or dependent variable that depends on the first variable, still in the context of regression, we use IV to stand in for the predictor, whatever variable you think is being used to generate the predictions. And we can call the DV whatever the variable we want to make predictions about. Even though that distinction is a bit arbitrary and you could flip what's the predictor and what's the DV, no problem. Just in the context of regression, conceptualize which one you think makes more sense as the predictor and which one you think makes more sense as the outcome. There's going to be a lot of output, but the main things you're going to want to look for, we're going to rerun some correlations. Since correlation and simple linear regression really do the same thing, and R value does pop up when you do a simple, straightforward regression value, but you also have your coefficient of determination, your R squared, which becomes a little bit more useful when you're running a multiple regression, as we'll get into. Your standard error of the estimate that indicates the amount of error in your regression model. The idea being, if you want to generate the more accurate predictions about your variables, you want that SBE to be relatively low. Then, to actually define the regression equation itself, your basic y equals mx plus b, we just use a slightly different notation here in the context of regression. So you've got your y-intercept and you've got your slope. In the case of our regression output, when we're looking for the slope, that's going to be defined as b or beta weights. So when you're reporting regression and pulling information out of the output, a lot of times you're going to pull out that b value, that beta value, and it's going to have a p-value associated with it. So that's going to be basically what we pull out of our basic regression. Then in multiple regression, this is just any regression in which you have multiple IVs in the model simultaneously. The idea being that any particular outcome is likely shaped by multiple factors. So if you have multiple predictors in the model, the idea is, will that help increase my predictive accuracy for the outcome? That is to say, will it lower the standard error of the estimate? Will it raise the R squared? But beyond putting more than one IV in the predictor box, multiple regression, you run it the exact same way. And you're going to look at the exact same output, but there's just going to be some unique things that you look for when you run various kinds of multiple regression. So this is basically going to be the output that we actually care about. The model summary box that's going to be at the very top of our output is going to give us all that information about the accuracy of our model. And down here in the coefficients is going to be where we find our slope, which is always going to be in this B column in the row next to the predictor. That's always going to be your slope. This value in that same B column in the constant row, that's our y-intercept. The significance value down here in the row with the IV is the significance of your regression model. If it's a multiple regression, there will be multiple rows for all your IVs, and this significance value is going to be associated with all the particular IVs. There's going to be a separate significance value for your various IVs. And so then we're going to talk about mediation. I would not blame you guys if you hadn't gotten a chance to look at the linear regression materials yet. I do have all of that posted, both the slides and my audio lectures. But really basically, mediation is when you're trying to understand why two variables are related. You might have two variables that you know are correlated, but you think to yourself, isn't there an intermediary between here? Isn't there sort of a go-between? So the example that I use in the lecture slides is a mediation from some real nostalgia research that was interested in how nostalgia helped shape relationship-oriented behaviors. The idea being the authors demonstrate that nostalgia tends to make people want to repair their friendships. And they thought, that's interesting, but I feel like there's more to the story. Is there a go-between? Does nostalgia boost something that in turn boosts these relationship goals? And they found that that was indeed the case. So there was a correlation that they sought to explain. And what they found was that nostalgia more proximally boosts social confidence. And it is only through the pathway of social confidence that nostalgia appears to be acting on intentions. If nostalgia was not boosting social confidence, likely you would not see that relationship between nostalgia and intentions to repair your relationships. So a really funky thing happens in multiple regression when you have a mediation, and this is going to sound quite counterintuitive, but this first pathway between the variables that were initially correlated will appear to drop to non-significant. And a very important point is to keep in mind that this does not mean the relationship between those two variables has disappeared in a real sense. That relationship is there and it's never going away. The idea is that when that pathway drops to non-significant, it tells you that the only reason there's a relationship between nostalgia and relationship intentions is through this pathway. So this is a very tricky point to wrap your head around. We're going to analyze a multiple regression that does this, and so really try and think about what this means. It's not that this relationship between nostalgia and intentions is going away or even changing. It's just that it's through this intermediary explanatory pathway that we know nostalgia ultimately works on intentions. It is only to the extent that nostalgia boosts your confidence in social circumstances that nostalgia can downstream have that effect on relationship goals. The mediation is tough to wrap your head around. In particular, it's tough to wrap your head around how this is different from moderation, but we'll have a chance to revisit that when we review for the exam. Definitely, it's a tricky concept. Now I'm going to shift gears to actually walking you through the lab quiz. These materials are here to help you remember how to actually run the analyses should you need to rerun anything on your own. Okay, does anyone have any questions before I move on to actually walking you through the lab quiz? I know it's kind of tricky. Okay, so now I'm going to reshare my entire screen so we can look at our lab quiz materials. As I mentioned, I think this is one of the, if not the most tricky lab quizzes of the semester, mostly because there's a lot of different steps, because that's kind of how we roll with regression. But it's not particularly hard. You sort of get into a rhythm of it and you run a lot of really similar analyses that I'll tell you slightly different things. So first, let's take a look at our prompt. All right, so we're gonna first start off by refreshing our memory on running a basic correlational analysis. Essentially, if you have variables that are uncorrelated, it's not even worth your time to run regression, because if correlation is about establishing that variables are even related, if your variables are unrelated, what's the point of generating predictions of one variable to the other? It's not going to generate accurate predictions at all. So a good first step is to initially run your basic Pearson's R correlational analysis. So we're going to do that first. And we're going to analyze, correlate, bivariate, and we're going to throw these variables in there. We don't need this health variable just yet. That's going to be more so for our mediation demonstration. So as we've learned, we don't need to change anything here. We can just hit OK, and then here's our correlation matrix. Again, to navigate the correlation matrix, the variables are listed downwards and side to side, and to find any particular correlation, you just need to find a box that represents the combination of the variables you're interested in, right? So you're going to report your R value and your P value for all your correlations. So for example, religiosity and social connectedness, the R value is 0.343, significance value of P equals 0.139. That is not significant. We know that because that is higher than 0.05, this p-value, and it doesn't have an asterisk. These other two do appear to be significant. Again, you're going to want to pull out your R value, which is in this Pearson correlation row, and your P value, which is the one beneath at sig two-tailed. Now, I know I mentioned this last time, and I'm gonna mention it again. Hopefully you're thinking to yourself, didn't Christina say something about P never equals 0? So like, what's going on here? I will reiterate because it's something that people forget all the time. This here, despite the fact that it says 0.000, is not indicating that your p-value associated with this r value is 0, because there is, I repeat, no such thing as p equals 0. There's always a type 1 error rate. What this means whenever you see 0.000 in SPSS output is that p is less than 0.005. So write that. Do not write p equals 0.000. Write p is less than 0.001. Now moving on to some of our regressions. So run a regression in which you use religiosity to predict meaning in life, and then you answer a series of questions to be pulled out of that output. So a regression in which you use religiosity to predict meaning in life. Here's how you do that. Analyze regression. Linear, like I said, there's a lot of kinds of regression. We're just doing this one. And let's see, it was religiosity to predict meaning in life, correct? So whatever is the outcome, put that in the DV or the dependent box, and whatever you're using to generate the predictors, your IV, into the religiosity or into the independent box. So religiosity goes there. You shouldn't need to do anything else. You just hit OK. And like I said, you get a fair amount of output, but you really only have to look here in model summary and here in coefficients. So let's see, you needed to get your R squared, your coefficient of determination. Up here in model summary, you have regular R squared and adjusted R squared. You can really write up either one. Adjusted R squared essentially always takes a slightly diminished estimate of R squared depending on how many IVs are in the model. Essentially, the more and more IVs you pack into a model, the more the adjusted R squared is going to sort of be slightly diminished to try and correct for the fact that you're slamming a whole bunch of IVs into the model at once. But since this is only one IV, you see that they're really basically the same. The more IVs you have, the more you might see a distinction between R squared and adjusted R squared. For our purposes, write up whichever one. Whichever number pleases you more. Standard error of the estimate, your SEE, the amount of error in the model. The reason these values are all together in this model summary box is that really an R squared value and a standard error of the estimate tell you the same thing. It's a quantification of the strength of the relationship between your variables, because the more strongly your variables are related, the more accurate your predictions. So there is an inverse relationship between R squared and standard error of the estimate. So down here is where you get the features of the regression equation itself. So you want your slope, y-intercept, and complete equation. As I mentioned, the slope is going to be the value in this column listed B in unstandardized coefficients. The slope is the value in the row with the IV. Okay, so your slope for this equation is 0.721. The y-intercept, of which there will always just be one, even if you're doing a multiple regression, is always going to be this top row labeled constant. And then to evaluate your significance level, your regression is going to be significant if your correlation is significant, if we're talking a simple linear regression that only has a single IV. So this is the same p-value that we saw up in our correlation matrix. Doesn't really add much, this p-value, beyond the significance value from your correlational analysis, but you do get that information about your slope down here. So then, complete the equation part of that question, you just have to use your slope and your y-intercept to create that regression equation that could be used to generate new predictions. Okay. All right, so then run a regression in which you simultaneously use religiosity and social connectedness to predict meaning in life. This will generate a new linear equation And we're going to look to see whether or not the proportion of variance explained has changed. So simultaneously use religiosity and social to predict meaning. Okay. So now we have a new model summary box that has new values in terms of the amount of variance that is explained in our outcome based on our IVs. So both social and religiosity together have a higher R squared in generating predictions on meaning in life than just religiosity. So the R squared value has gone up. The standard error of the estimate has gone down. Think about what that tells you in terms of generating predictions for the meaning in life variable. The idea is we know how strongly religiosity is associated with meaning in life. Are we strengthening the accuracy of our predictions when we throw social connectedness into the model as well? To figure that out, you have to think about how your R squared value has changed and or how the standard error estimate has changed. Now you notice down in the coefficients part of the output, we're still going to get the features of our regression equation here. Once again, you've got a single row labeled constant. That's your new y-intercept. And notice that now there's a separate row for your two IVs. For any multiple regression, your regression equation is going to have a term for each IV, and each one is going to have its own slope. So this value here in the religiosity row, that's the slope for the religiosity IV. This here is the value for the social connectedness IV. And there's a separate p-value row for each of the slopes. This tells you whether or not in the multiple regression that religiosity has a unique, strong predictive accuracy for meaning in life, and social connectedness does as well. This basically tells us that both religiosity and social connectedness independently have a strong amount of variance shared with the DV of meaning in life. So for that question, you're mostly going to want to generate your new equation, and you're going to want to think about how the model summary has changed. Okay, so that is your part one. Like I said, there's a lot of analyses to do in this lab quiz. They're all a little bit repetitive. It's just slightly different each time, making sure you know where to look. So now let's move on to part two, where we get to think about mediation. So first off, run a series of regressions to establish whether all the pathways in the mediational model are significant separately. So this is what you do before you run the mediational analysis to ensure that all of the criteria for a mediation are present. Basically what that means is that for a mediation to be possible, all of the factors in the mediational model need to be related to each other. What this means is that the initial relationship that you're trying to make a prediction about, that pathway, which is going to be the bottom of this triangular model, right, with your first predictor here and your DV here, you need to establish that this, we call it a pathway, is significant. That's because we need to indicate that there's even a correlation there to be explained. So then run a regression in which you use social to predict meaning. Then you do a regression to see whether or not meaning is associated with health. So this is establishing that all of the factors in the model are associated before we get to our last multiple regression to assess for mediation. So I'll show you how to do this first one. You'll just need to go through and do the same thing for the second two of these first preliminary regressions to try and figure out whether or not mediation might be present. So analyze, regression, linear. Now in this case, we're going to use, was it social connectedness? Social connectedness to predict health. This is to establish that that pathway at the bottom of the triangular model is significant, which represents that first correlational association that we're trying to explain. Okay, so this is our output. In order to answer this question, all you're going to need to pull out of here is the beta weight, i.e. the slope, and the significance value. This tells us that there is a significant correlation to be explained. Now, the reason you're just pulling out this beta weight and the significance value is that typically when you see a a regression write-up, that's the primary numerical output that you see reported, your slope and your significance value. So that's what you're going to do for these next 3 questions, where you're running social connectedness to predict health, social connectedness to predict meaning in life, right? Your first predictor needs to be associated with your proposed mediator. And then lastly, for this first question in part 2, indicate that meaning in life is associated with health. So your mediator, your proposed mediator, needs to be associated with your hypothetical outcome. So you're going to want to run those 3 regressions and pull out your slope and your significance. Okay, so then the real fun starts. We're going to do one last multiple regression to evaluate whether or not mediation is present. So to do that, you put both the first IV and the proposed mediator simultaneously into the model in the independence box, right? So it was social and meaning, still predicting that single outcome. Things have changed. When both social connectedness and meaning in life are simultaneously in a model to predict physical health, what we see is that the pathway associated with with social connectedness has dropped to non-significant. You know that because this significance value has changed to now not be lower than p equals 0.05. It is now not significant. I'll repeat that this does not mean that that first correlation between social and health has actually disappeared. The data is what it is. That relationship is there. What this tells you is that social connectedness appears to be impacting physical health through the pathway of meaning in life. Social connectedness only predicts physical health to the extent that social connection makes your life more meaningful, which then in turn more proximally impacts your physical health. So that's what this non-significant relationship tells you. I'll say it one more time because people always get this wrong. That relationship has neither disappeared nor even changed. It's just now that we can explain it via a mediational pathway, and that's what mediation is. So then lastly, you're just going to want to fill out your triangular diagram. You're going to want to put the first IV down here. The proposed DV should be down here. And up top, whenever you've got this triangular mediational diagram, your mediator goes up here at the top. Because what this diagram is meant to convey is that there's this underlying relationship that exists via this series of pathways. So that's how you fill out that diagram. So again, take some time to fill out the rest of your questions. There's a fair amount of analyses to do, but they're largely a bit repetitive. You just need to know what information to pull out of which analysis. So definitely read the questions in the prompt closely, review those slides that I'll be posting when we're done here, and try your best to think about what mediation really means. You should be good to go. So I'm going to end the recording here and then take any questions.